Hello, everyone, and welcome back to the DENPAFLUX podcast. I am Zach Peterson here with Chief Commercial Officer of DENPAFLUX, Marc Haag. We're going to be having an enlightening discussion today, and I think it's going to be a good opportunity for everybody to continue meeting the leadership team at DENPAFLUX. Marc, thank you so much for agreeing to do this. I know this is, I think, your first time doing a podcast, so it's going to be a fun ride.
Absolutely. Thank you very much, Zach, for having the opportunity to have the podcast with you today. I'm also looking forward to this one. And yeah, as you were saying, first time, but that should not stop us to have a good show, right?
Yeah, exactly. So I guess just to get everybody comfortable with you and to learn more about what you do at DENPAFLUX, if you could just give us your background, tell us how you got started at the company.
Oh, okay. So first of all, I'm not the EMC guy here at the company, surprisingly, but also my job is to make customers happy, right? So I'm the commercial lead here at DENPAFLUX, so taking care of everything what has to do with our customer base. So starting from marketing over sales and customer success. And I joined 2 years ago at DENPAFLUX, and before that I was working almost 18 years in automotive and were taking care of commercial projects. And when it comes to those kind of things, there are only three things what are matter. It's cost, it is timing, and it's quality of a project. And when I started with DENPAFLUX 2 years ago, it came very, very much easily to my mind. They're saying it's so interesting that EMC challenges are hitting those three things, right? You can miss your timeline, it can explode your cost, and it can also jeopardize your quality. So that was really something where I could relate from my previous job with, or with my previous career with. And now I see my role like this one, that I'm saying EMC is not only a technical issue, it is also something what is diving into your business case and can make or break your business case, actually.
Yeah, I would absolutely agree. And I think companies that can get some sort of competitive advantage in the area of compliance can get to market faster, capture more market share, those types of things. But usually when we talk about compliance, people think about, I think in the electronics industry, they think most about like RoHS, right? They think about environmental compliance.
Mm-hmm.
They don't really think about EMC until they go through testing and fail. Would you agree?
Yes, absolutely. And for me, it was also the same way when I was joining or sitting on certain commercial projects. You are eager to win the project and to develop this. And then you get the list of documents or standards you have to fulfill and comply. And to be compliant, and you're saying, no worries, I will do that. That is not a problem, right? And for a lot of companies or for a lot of teams, being compliant is kind of binary. It's on off, right? Either you can do it or you can't do it. And there is a difference actually. But how should you know if you never came into the position that you had time to dive into it and to understand that I can do more than just pass the test, right?
Yeah, I agree with what you're saying. I think what's interesting about this is the fact that it always comes up as a bigger issue late for companies who may not have experience in this area or who don't fully appreciate some of the challenges. So as a result, maybe managers or CEOs don't get involved as early as they should. Would you agree with that?
I do agree with this one. And I think the reason for it is that something like EMC is being seen, it sticks with the engineers, it sticks with the development teams. And nobody's actually translating that into the language of a leadership team or a CEO, which is normally very much behind, are we right on time with our product? Does our product hit the cost base, and can we sell it for the price we are assuming we want to sell it for? And there is no space in those kind of discussion to deep dive or drill down into EMC.
Yeah, I think I I think I agree with you there. I think one thing that's interesting about, keeping it with the engineers is that it's almost seen as like a checkbox, right? Because
Hmm.
I think other areas of compliance actually are seen quite often as checkboxes, right? Or at least the industry has done a lot of work to make what would be something that, yeah, sure, there might be audits involved, but the information that's available to engineers allows that area of compliance to be like a checkbox. I think like with RoHS or Reach, right? The vendors of components and materials and all this, they make all the information available for you to make it a checkbox, if you like.
Hmm.
And with EMC, because there's actually a level of testing and rigor and analysis, it's really hard to make it a checkbox.
Yes. And I think when we are talking about this not being a checkbox, what comes to my mind is there is so many connection points when it comes to EMC to other areas like security or functional safety and stuff like this, right? Where you have to consider this as well. That makes it so hard. It's not just only ticking the box, it is also to say, is it compliant with the other disciplines, so to say, right? Is it good for me in a way that I have a very good, efficient design? I believe that is also very important there.
So ultimately, at the end of the day, CEOs are going to care about two things, right? Money and time, right? So
Yes.
if you could take the EMC process and maybe translate it into something that's a little more, I guess you could say, meaningful or tangible to somebody who's running a business in those terms.
Hmm. I believe when we are looking at this one, we need to bring those functions together which are working on developing a product. And product development is not only related to the engineering team, which is doing all the efforts in to have a product which has great performance and is compliant. It is also about decisions like in purchasing what kind of material I want to use. Most companies I know have preferred products or components they are sourcing, preferred suppliers where they are working with. And this is also limiting then the choices you can do. So there are certain things you might not see. And this is, I think we need to work on this more to bring this full picture in. What I always like to use also as an example is an EMC filter, right? If you think about how to filter upfront, it's easy. It's a design decision which you can put on your PCB rather than an add-on component later on into your product, which is sitting there and needs to be wired up inside of your product and is bearing a lot of cost, right?
Yeah, that's kind of a reactive approach, I guess you could say, right? They
Hmm.
find that
Absolutely.
there's a failure in the lab, and then they're scrambling around trying to find just the right filter that they could probably use to just see if the current setup will pass. And in
Exactly.
fact, it's interesting that you bring up filters because just yesterday or the day before, I saw a LinkedIn post from somebody who was talking about exactly this issue, right? Everything looked like it was going to be great, and then all of a sudden they failed in the lab. And so now they're scrambling around, being reactive, trying to find, can I throw a ferrite choke on this cable, or can I just hook up a filter module on the input, things like this.
Mm-hmm. Yeah, and this is too late, right? You're in and bringing in what I call hot patching, where you bring in certain solution at a point in time where you don't have any more the time. When think about you're weeks away from your launch of your product, like manufacturing has set up all the processes already. The pipeline is full with the components which are coming to your factory so that you can manufacture these things when you are having a big scaled operation. And then you're coming back from EMC test, which failed, and then you're looking for everything what could help you to make it work. But that is a decision for the product right now to bring it to the market to hit the point, but it's a bad decision for the business case.
So I guess if you could, tell us, or make the business impacts a little more tangible. What happens after, maybe you go through this reactive process and, okay, fine, it works, you pass. But what's the ultimate impact on the product and even on the company?
And this is where absolutely we can talk about this. I believe this is also where I would love to see more people helping engineers to understand that from a commercial standpoint, like controlling and sales as well, to say, what does it do to my product? What even does it do to my reputation? Because certain things are tangible and some are intangible. You cannot see them. But let's walk down the road with this EMC filter, by example, right? So you're coming out of the lab, you have this EMC filter, and it works. It's super. It's good. So happy days. It makes you able to launch your product. But what does it mean? It means more complexity in your supply base. You need to ramp up another source for a component, which needs now to get into the project. So your purchasing is looking out to get this sourced. Secondly, your manufacturing guys are also very happy to bring that into the manufacturing process and to see how to enable this assembly then. And third is then also, like, when we are looking on the cost calculation, and this is where controlling comes in, you have now something in your product which you supposed not to have in your product, most likely. And it is a little bit the question, can you give that to the consumer or to your customer with a higher price, or would the higher price then also lead you to disadvantages because other vendors can have the same product in a more efficient way for a better price then? So you're losing a lot of opportunities there, which is very hard sometimes to estimate or to see how much it is, but they are out there. And I'm a big fan of having simple calculations to see that, not really over sophisticated. You can make it with a 3-step calculation. There you say, okay, what is it doing to my supply base? What is it doing to my manufacturing? And what is it doing to my margins, right? And then I get a very good feeling about it.
Yeah, the margin aspect and what's it doing to your supply base, I think that's becoming much more of an issue, because being able to quickly get solutions, let's say overseas, that was a good way to keep your margin, even if you had to kind of go in an emergency and get a component, right? It was always just in time. So now these days, things have changed quite a bit globally, and going back to your supply base to try and get the component you need at volume could actually be quite difficult. Either you might not be able to find it, or, okay, sure, you can find it overseas, but the cost structure has totally changed, and probably the lead time structure.
Yes, absolutely. It has a complete influence on your product and the whole behavior, how you're handling the manufacturing and the distribution of your product.
Okay, so clearly some level of expertise in EMC is going to be a competitive advantage. I think there are a few different areas where you can realize that, right? There's either expertise in just being the guy who can maybe do pre-compliance and debug and identify that issue last minute before you go into formal testing. I think the other aspect is understanding the process and when is the right time to either engage with a consultant or start running simulations to try and identify problems, these kinds of things. And I think that probably starts to show why CEOs kind of treat this like a checkbox, because it feels like those are some of the same tasks you would be doing for any other aspect of a design anyways.
True, and sometimes it's also pushed out a little because engineering teams are saying, let's wait till we have a final design, till I understand where I want to go, right? In certain stages, it's being overseen as something like, no, it's not the right time yet. I have not chosen my components, by example. I have not my active components. I'm not sure what I want to use or something like this. However, it's like, EMC becomes more and more, from our point of view, a discipline throughout the whole process. When you start to write your specification, it's already pick and choose your technologies you want to put in, right? If you have near field communication, that is a game changer, perhaps because you never did it before. And there you should already start thoroughly to think about it. However, what I also see in the market and with customers, there is also, I guess this is coming also from CEOs or from leadership team. You want to be efficient as possible. Everybody wants to be efficient as possible when it comes to engineering and to manufacturing, right? And this is where the team focus first on the performance of a product and say, okay, EMC later on. So ultimately, what we believe and what is a great thing, have a checklist. You even don't need to have a consultant, but have a checklist for yourself to see if you are touching base on a certain point in the product development that you have an idea about it. Like which standards do you have? What kind of technologies are putting in the specification? Then later on, when you go on with your product development and say in the architecture phase, have you outlined it according to EMC? And this is going all the step further. And whenever you have that as a little task on your list, then it cannot become a big task at the end, which is jeopardizing your whole product.
So if you could give us maybe one or two examples of bringing in EMC from the very beginning, right? I mean, you mentioned standards and these kinds of things and you know, keeping an eye on those, what those requirements are going to be from the test standpoint and the regulatory standpoint, which, you know, of course makes perfect sense. But in terms of the actual design or engineering tasks early on, what do you see as a couple good examples of bringing EMC in early?
A very good example for me is like to review and assess the standards which are applicable to your product, because you do that at the beginning of your process where I know what I want to develop. I know in which market it will go. I know in which kind of electromagnetic environment it will operate. So I can make a very good assessment at my specification already at that phase, very, very at the early beginning. The funny thing about it sits then for a long time on your desk, so to say, right? And you develop in something like this, but it becomes really interesting when you go the first time to the EMC lab, because most people think about it that when they go to the EMC lab, that they are coming to someone and say, I want to have my product EMC tested. And the lab is then saying, well, so which standards? And when you have not determined that, or this is when you are starting then to think about it, this is too late, because then the design is done, your prototyping is done. And that's why it's so important to have it early done, that you can really design according to it and that you can test according to it. Matter of fact, also, as a manufacturer, you are responsible to determine and to assess the standard you want to apply to your product. It's not the EMC lab. It can support you, and they're all doing really great jobs to support manufacturers. But ultimately, you can give not this kind of due diligence to someone else. And this is really where I saw that learned by the hard way, where companies were putting it really to the end. And then they had to catch up again and say, did I really do this according to what I want to do, or do I have to go back now?
So in terms of trying to figure out, let's say, the right design decisions for ensuring EMC, right? I think people I think in the past and even currently today, everyone's relying on two things, right? One is somebody who's very experienced, assuming they've already accepted that this is going to be very important and is a product risk. They're going to rely on hiring the right people who have some level of EMC experience, which can be tough. And then if they can't do that, they're going to rely on some level of simulation.
Okay.
How do companies find that balance between, human expertise and then simulation or some other kind of automation to try and converge to the right design?
That's a good question. First of all, you're on a good way when you as a company realize, this is important and I need someone with the expertise in EMC. Then you're already doing the right work, because this is when you think about it and you say, okay, how I can mitigate the problem. Simulation, I take it simulation versus human expertise. Let's call it this way, right? As you know, I'm not the tech guy within the company, but I have like the view as a project manager or project management perspective, what I can give on this one. Simulation is powerful, that's for sure, but it's not magic. It follows certain algorithm, it follows decision trees, mathematical equations and stuff like this. What does it mean? It follows a simple rule. If you are giving garbage in, you get garbage out. Sorry, my language, but it is what it is. So you need to have a very accurate model of your product to get a very accurate simulation result out of it. Does it work at the beginning of the development cycle? I don't think so, because you are having so many moving targets, and you try to bring them all together in one basket, and that is very, very hard. So I believe simulation is doing a great job when your product development is quite mature, when you are having a very, very heavy product in regards of complexity, and when a test campaign would take a lot of time. Then you're right with simulation. Sometimes, I have to be fair, simulation is taking too much time, and you're even faster with a probe to sniff it out on your own and to really see what's going on. It's really hands-on then.
Yeah, I think the other issue with simulation is that to like really avoid the garbage in, garbage out problem is you have to have somebody who, they have the PhD in computational electromagnetics, right? They have to really deeply understand the tool, because the simulation domain spans from, micron level length scales all the way up to, millimeter and centimeter level length scales. And you can brute force it with a simulator, but like getting that work done to be accurate and also not take a week for simulation time. I'm being, a little exaggeration here, but you get the idea. You have to find somebody who really knows how to set this up and do it in an efficient way. And that's also really difficult. Probably easier to find an EMC expert.
I guess so. And you're bringing up a very good point, which I haven't thought about it. It is really the time issue. It takes a long time, and also the expertise. It's not by default. There are like job description of a simulation engineer, right? It's like it is there for a good reason, because you have to have this knowledge to have a good simulation to run, right?
Yeah, absolutely. So in the simulation aspect, right, you mentioned bringing this up when the product is quite mature. But I think the other challenge with simulation, and where you might prefer a human expert, is not just when you have the PCB, right? Because in any real product, you have the PCB and its enclosure and its cabling or wiring. And maybe there are some other specialty materials like underfill or thermal interface material. Maybe there's heat sinks, there's fans. Like it gets really complex really quickly, and trying to get any kind of, reliable measure of the electrical behavior in the presence of all of those elements, I think suddenly becomes extremely difficult, even with the best simulation tool.
I think so too. And there is something what I think we should also consider. There are so many people behind that which are influencing design decisions. Like there is also coming back to the commercials again, right? They are also saying, don't you dare, don't make it more expensive. And then you are also sitting up and say, I need creativity in the EMC process. I need to find solution which I can also assess and say, what is good for my manufacturing process? What is good for my sourcing process? What has commonality with other products and stuff like this? Simulation doesn't do this job, because simulation is really just spot on that you're saying, I'm good with my decisions, which I have to do around in my environment with all those shareholders in the product. And once I have done that and I have peace of mind in that regards, then I can go with simulation. Anything else, we're coming back to this moving targets, right? Where you want to have a lot of options where you can go first.
So which industries are dealing with this to the greatest extent? Because simulation and human expertise, right? I mean, depending on which industry you work in, you're going to have different levels of expertise that have kind of, clustered around certain industries.
Mm,
I think if you work on, let's say you work on wireless products, right? There's a lot of simulation experience there because of course they do like antenna simulations and these kinds of things, right? So that
yes.
makes a lot of sense that they're going to be better at it than other folks. And I think they're probably going to be better than at EMC than other folks. But maybe for some consumer products or even a startup, like, it's such a big question mark what the level of expertise in either of those areas is.
You're bringing up a very good point. It is, how can I say that? There are many factors actually we have to put into consideration if we're saying who needs EMC support or who needs to consider more about EMC than others. One is for sure, it's like the expertise level when you're saying a startup. A startup works very different than a corporate company. When you are having a product or when you are in the business for 50 years and you're working in a certain sector, already you have established certain design guidelines and rules and you're developing from there. So you don't develop from scratch. But with startups, there is, and even us as a startup, there is so much going on in a startup where you say, I don't have the expertise, and it's good to say that. I would really recommend to companies not to be naive and say, hey, let's have a wide gap analysis. Can we do it or not? And I have seen a very interesting product I have seen where a company was a medical company, a medical startup. They wanted to use a sensor from the building industry, which is being used for earthquake, to do some monitoring of patients. And they were taking a device which were like being released for the construction industry into medical. And they were really like, how do I do this? What do I need to do? How do I know it is classified for the uses in construction and the standards are all fulfilled? And now medical, what do I need to do? And there, I think when we are coming to this point, those people should focus on getting the product to the market. This is what they want to do, and get the experts in for those questions, because yes, it costs money. I get that, but it saves you a lot of time, and you don't have to have time for trial and error on those kind of things when you can just pass through and say, okay, those guys from DENPAFLUX can help you to get to the point where you have your EMC ready and within time when you need to have your product on the market.
So obviously DENPAFLUX being active in EMC, I'm sure you guys, I don't know the whole customer base and what the distribution is, but I'm sure you see a lot of diverse companies from different industries. So which are the industries that are feeling it the worst?
There is for us our customer base is quite diverse, and it sounds a little bit like I want to dodge this question, right? But it is something what we are observing when we are looking at like the industrial megatrends all over the world. So devices are getting very small, getting smaller and smaller. They have more functionalities. They are more wireless than ever, and they are all working in a very confined area. So everybody who's working in those kind of surrounding is actually also challenged with EMC. And we can have two examples. Industry 4.0, which is now becoming industry standard when we are coming to manufacturing. You have sensors, you have moving devices which are autonomous. You have radar, you have different signals, and you all have that on your ground floor, on your work floor, in your factory. There's coming a lot together, and you want to ensure that none of those devices are disturbed by each other, and that they are not disturbing each other, right? And looking also to automotive, by example, electric vehicle, we have now this high voltage powertrains inside. We have autonomous driving inside, technologies, infotainment system, which are getting loaded up with high resolution, and those are all prone to EMC, right? So the question is, you can always have a call with us to have an honest look into your product and say, how much are you affected by that? But the reality is that the industry, or like how we are moving with our technologies towards, it becomes more and more an issue, or more and more a challenge, let me say it this way.
Yeah, I like how you brought up the mega trends, right? Because I think this is an area where you certainly have the legacy companies, let's say, right? Much more experience. They have processes, they have people, they probably have their own internal labs where they can go and do some EMC testing and really try and figure this all out. But, these mega trends are seeing a lot of investment, and that's driving a lot of startups to get into these areas. And I think it's also driving some established companies to maybe get into a new market where they don't really have the experience needed to really understand the full range of EMC challenges.
Right. I agree with you. And what I have also the feeling is that startups are always moving much faster than good situated companies, which are there for 50 years in the market, because they also have established processes which are working quite well, no doubt about it. But I call them the young and wild. They are here to get their certain share from the market, right? And if you are not playing those kind of games with the young and wild, then you might lose your opportunity. So there is a good chance, or this is also something where I can say to CEOs and to leadership teams, always have a look on those kind of trends, how to, by example, taking care of EMC. This reactive mode has become our industry standard. What we mentioned before, there you say, hey, you develop your product, then you do a prototype, and then you test it out. If it doesn't pass, you do the next iteration. But there must be something better. It also must be something better there when it comes to the mega trend, when we are coming about being resourceful, right? And putting every time to throw out new prototypes, and also having excessive material when it comes to EMC on your product, like EMC filters, additional one, ferrite beads, at the cables, foil, and whatever is there to mitigate EMC. That is also from an environmental standpoint something where you can differentiate yourself.
You just mentioned something interesting, which is like over designing for EMC. And I think that's another reactive aspect, because I've been asked to do design rework, and I've talked about this with other EMC consultants and experts, where, a company will go through testing, they fail. They didn't even do pre-compliance, they just failed. Then they start doing some research, finding whatever system level and PCB guidelines they can come up with to hopefully solve the problem. And then they come to you, a layout person, or to me, to implement this laundry list of fixes. And they don't actually know what the cause of the problem is, but they're pretty sure this list of 10 things they came up with will fix the problem.
Yeah, you make me smile about it because I think about legacy programs, right? You're inheriting one program in version 1, then you come to version 2, 3, and 4 about this one, and then you're asking about certain components on the PCB and say, why is it there? And then the question or the answer from it had always been there. It's like it's so interesting how to see it, and this is where we're also saying. We want to challenge actually products which are also in the market. EMC is not only a thing what you can do while you are doing development. It's also a good housekeeping process, I believe. To have a look at your product which is in production right now, and if you have the feeling that you have used in your current version a lot of ferrite beads at cables or stuff like this, or like mitigation technologies, have a look at it. You can avoid those, and a redesign might be worth to do it, and you put them all together, that you come to a clean design again, and you can start off fresh. This is how I feel about it. And so far, to be fair, I hadn't had any luck to find someone who wants to really look into it, because there is this kind of, that is a lot of work, and companies want more to go to new, exciting new projects rather than cleaning up their homework or their legacy programs. But I would challenge out there the industry and say it's worth it to do.
So tell us then, obviously with DENPAFLUX being active in EMC and helping customers address some of these challenges, where does DENPAFLUX come into this whole process?
You mean now in the typical product development process, or during those kind of things like the house cleaning or the housekeeping?
Well, I'm thinking more in terms of the product development process, right? Not just house cleaning. Although I'm sure, you can very easily engage with DENPAFLUX to look at, simplifying a design and doing the type of house cleaning you're talking about.
Exactly. So normally there is no limit about it where we start to work with the customer. Ideally, as we talked about, think about EMC instantly when you write down your specification of your product. That would be sweet. That would be the best spot, because then, as we were talking about it, then it's only a little task, and we can keep it little for you for the time. But we can come in at every stage of your product development process. What is interesting, the first time customers which are coming the first time to us, they normally engage with, they have an understanding about, before I go to testing, I should do something. And before I do my first prototype, it would be great to have a peer to look at my design. And they are coming in at the layout, the PCB layout, and we have also looked at the wiring harness or the mechanical concept. And once they understand that, and it makes click with them, and say, okay, this is great because I already saved some time. And when we are saying, now put it even earlier, do it in the architecture phase, do when you think about your grounding concept and stuff like this, where you don't have to, layout work is already cumbersome, but there it is even easier to do. Customers are coming more and more earlier back because they understand that. So in a nutshell, we can do everything at every stage, but ideally as early as possible.
Certainly. Well, my hope is that folks who are understanding that they need to get better, let's say, with their EMC processes and expertise, will be hearing this, and they can reach out to DENPAFLUX, or possibly even reach out to you to start that process earlier in the design phase rather than being reactionary. So if you could tell folks how they can get in contact with, if you could tell folks how they could get into contact with DENPAFLUX.
There are several ways. So, we have our platform where you can enroll yourself, and you can even instantly upload data, and we are getting in touch with you through this upload of the data. You can drop us an email or request a quote through the web page, which is called denpaflux.com. And of course, you can have instantly a talk to me or write me an email, because I'm also here for the customers, like everybody else in my customer success and in the go-to-market team. So my email address is my first name dot last name, marc.haag@denpaflux.com. Happy to help.
Okay, well, I hope folks out there who are listening and watching on YouTube will hit the like button, hit the subscribe button, head over to denpaflux.com, get in contact with the folks at DENPAFLUX if they have EMC challenges they want to solve. We've been talking with Marc Haag, Chief Commercial Officer at DENPAFLUX. Marc, thank you so much for being here today. And of course, I'm sure we're going to see you here in the future to discuss all these issues as the platform and the capabilities at DENPAFLUX continue to grow.
Zach, it was a great pleasure today, and it wasn't so hard as I thought it would be for the first time. So thank you very much for having the talk, and yeah, till next time, I would say.
You're a natural. Thank you so much. We'll see y'all. We'll see everybody later. Bye, everybody.
Thank you. Bye-bye.